Welcome, my fans. We have a question under linear expansivity. It said a wire of length 100.0 meter at 30 degrees Celsius has a linear expansivity of 2 times 10 raised to the power minus 5 per Kelvin. Calculate the length of the wire at temperature of minus 10 degrees Celsius. Now, let's go this way now. So we have solution. In my last video, I derived all equation under linear expansivity, right? Isn't it? So now don't forget that your linear expansivity's formula is change in what? Change in length, or L2 minus L1 over L1 and what? And change in temperature. Okay? That's formula for what? For linear expansivity. So now this L2 simply means the final length, while this one means what? The original length, or we call it the initial length. So you either use this or use this. So depending on what one that you feel like using. So now let's take a look at the question again. It said a wire of length 100.0 meter, that is the original length is what? L1 is 100.0 meter at 30 degrees Celsius. That is the theta1 initial temperature, that is original temperature of the wire is 30 degrees Celsius. Has a linear expansivity of, that is this sign here means the linear expansivity, that is the alpha equals to 2 times 10 raised to the power minus 5 per Kelvin. Calculate the length of the wire at temperature of minus 10 degrees Celsius. That's theta 2. You have to calculate the length of the wire, right? At temperature of what? Temperature of minus 10 degrees Celsius. Now let me quickly remind you of something now. If let's assume the answer of what? Of this question. If the length is 100, temperature is what? Is 30, right? Initially, before it is what is being applied to it. And why the expansivity is what is given as this, right? Notice that the length is now minus 10. Now, what do you expect that the final length of this material will be? If the temperature reduces to minus 10, definitely the length also is going to reduce. It means that the length cannot meet up what the original length of what of the wire. You get what I'm saying now? So let's quickly write the formula. Let's focus on this formula now. So the linear expansivity is given as what? Is given as 2 times 10 raised to the power minus 5. Then equals to, let's say we are not giving length, right? Let's take that as change the length as unknown, then over. So let's go. Now the reason I make this one unknown is because this L2 is not given. We're only giving L1. So I just assume that both are what? They are unknown. Okay? So then all over the L1 is what? Is we have 100 here. That is 100. 100 is the same thing as 10 raised to the power of what? Of 2. Then we have 100, same thing as what? 10 raised to the power of 2. Because we have, look at this here, we have 100 here. How many zeros do you have here? 2 zeros. That will be 10 raised to the power of what? 2 will give us what? 100. 10 raised to the power of 2 simply means 10 times 10, that will give us 100. So if you write 10 raised to the power of 2, I put only 100 here. You are still correct. So let's go now. Then times. So what is temperature given is what? Now given to temperature, we have theta 2 is what? This theta, this change temperature means that we have theta 2 minus theta 1. That's what it means. 10 raised to the power of 2 brackets. Theta 2 is what? Is minus 10. This is at theta 2 here. That is minus 10. Then minus, what is at theta 1? 30. When you hear something like change in temperature like this, it means that we have theta 2 minus theta 1. Theta 2 is doing the expansion, that is minus 10. Theta 1 is what? The original temperature of what? Of the material, which is 30. So that's what you have in that place. So we're going to be having 2 times 10 raised to the power minus 5, change in what? In length, over 10 raised to the power minus 2. This one will give us what now? That is minus 40, right? So we only have times minus 40. Okay, so let's cross multiply here to make this one the subject first. So we have change in length equals to 2 times 10 raised to the power minus 5 times 10 raised to the power of 2. We have times minus 40. This one multiply what is here. So that's what we have. So let's take the other side of the board. So now let's multiply it now. So let's say we are multiplying what? The one that does not have a standard form, which is 2 and what? And minus 40. So 2 times minus 40 will give us what? Minus 80. Let's say we have minus 80, then times. Now when you look at this one now, we have 10 raised to the power minus 2, we have 10 raised to the power 2. This is likely what now? Law of indices, right? Which is multiplication law. and we have the same base, just pick one of the base and you add the power together. So let's do that now. We have 10 raised to the power of minus 5 plus 2. Minus 5 plus 2. So we have change the length equals to minus 80 times. So I'll give us 10 raised to the power of what? Minus 3. Right? So you can see turning back to what? To its normal terms, which is standard, which is decimal fraction. This minus 3 means that we have 0.00. Then put this what? You put this number there. Put minus first, because I have minus. That would minus 0.0080. That's what this simply means. This minus that is here, this is it here. 10 raised to the power minus 3, 0.00. Then we have put what? 80 there. Okay. Now let's go back to what we have to find now. Now you've gotten our change in length, right? But don't forget that your change in length formula is L2 minus L1 equals to what? L2 minus L1, that's this change in length, that's what is here. Then equals to what we have here, minus 0.0080. Now, we are given one of the length, right? The length given is what? The original length given to us is 100. So let's take note as 100. That is definitely, we want to find this L2 here. L2 minus, this one is what? 100. Then equals to minus 0.0080. So collecting like terms now, we're going to have L2 equals to, so I'll change to plus. We have minus 0.0080 change to plus 100. So let's see what I'm going to have now, the final answer. When you subtract, let's see, we have minus 0 points anyway. We have minus 0.0080, then plus 100. That will give us L2 equals to 99.992 or 2, what we have here? 2 meter. Now, according to what I said before, I said the length is going to reduce, isn't it? Because what? Because the temperature was reduced to what? To minus 10. So that means that this temperature is what? This temperature is this, when you have something like minus 10 degrees centigrade, it means that it's very cold water temperature, right? Now, when the length was 100, the temperature was what? 30. By the time the temperature reduced to what? To minus 10, definitely going to affect what? The length as well. Can I see the length now? 99.992. Why the original length is what? Is 100. Can I see the difference now? So don't forget what? I believe that you enjoyed this video, right? Yeah, now like it, share, comment, right? Thanks.